Okay, today we're going to work on problems 21 through 30. For number 21, it says that we need to simplify our problem 2 over y squared minus 2y minus 1 over y minus 2. The first thing that you're going to need to do here is you're going to have to simplify your denominator. So let's go ahead and let's take a look at this one. We can pull the GCF of y out of both of those things in our denominator, and we'll rewrite. And then this can't be broken down any further. So what we have now is we have this. Now, to make these a common denominator, you're missing this piece over here. So you have to multiply your top and bottom here by the y so that you can have a common denominator. Now what we're looking at here is we have 2 minus y over y minus 2. Now, you would think that you would be done here at this point, and just take notice that they don't give you that option in your choices A, B, C, or D. So you need to see that you can do something with your numerator here so that you can end up simplifying or eliminating some things in both the numerator and denominator. I'm going to take this 2 minus y, and I'm going to rewrite that. That's like rewriting it as negative y plus 2, or I can pull a negative 1 out and have y minus 2. Now let's rewrite our denominator underneath that, and we have y minus 2. Now you can see that we can eliminate our group of y minus 2, leaving you negative 1 over y, which is your choice B. Number 22 is similar to what we just did in number 21. What we're going to have to do here is we're going to have to factor both our top and bottom. So let's go ahead and let's factor our top here. And that is going to give us, notice there's no middleman, and those of you that have had me for class, you know that that's how I say that, when the middleman is eliminated. You're going to have m minus 7 and m plus 7, because 49 is a perfect square, and then if you would add a negative 7 and a positive 7, they cancel each other out, therefore no middleman. Now let's take a look at the bottom. Remember, in this one we have to find what's going to multiply to give us negative 14, but add to give us 5. Well, you can do plus 7 and minus 2 because they multiply to give you the negative 14, but add to give you the 5. Now we can eliminate groups, and you're left with m minus 7 over m minus 2, which is going to be option B. Number 23, it says, for what value of x should the expression 5 square root of 5x be further simplified? In other words, what it's asking you to do here is it's asking you to put those values of x that it gives you in, and then see if under the radical, after you multiply it by 5, you can break it down or simplify it. So I'm just going to go and do each one of these. If I did 5 times 2, that gives me the square root of 10. Can I further simplify that? Can I break it down by one of our perfect squares? 4, 9, 16, 25. The answer there is no. So this would not be an option for us. Let's take a look at 10. If I did 5 times 10, that's going to give me the square root of 50. Can I further break that down? In other words, using those perfect squares of 4, 9, 16, 25, this actually you can break down. You can take the square root of 25 times 2, which gives you 5 square root of 2. So this one can be further simplified. So at this point, you shouldn't have to do any of the others, but at least you know the steps of what we're doing there so that you can also look at number 24, which is going to be similar. For number 24, it gives you the square root of 34x. So it's exactly like 23. We want to figure out which one of those values I can plug in so that my square root of 34x can be simplified. So go through and do your 34 times 5, and you've got the square root of 170, 34 times 7, that's going to give you the square root of 238, square root of 34 times 13, and that's going to give us square root of 442, and then we have the square root of 34 times 17. That's going to give us the square root of 578. So take a look at your perfect square list. You've got the square root of 4, square root of 9, and see which one of these 4 options will be able to be simplified using your perfect square list. For number 25, it says find the least common multiple. Alright, so we've done this in class, and I think I've shown most of you how to find the least common multiple using the calculator. Alright, so taking a look here at number 25, what I want you guys to do is I want you to take your calculator and I want you to go to the math button. It's the third down on the left hand side. I want you to go there, and then I want you to scooch over or go over one spot to the number column. Then if you scroll down in your calculator, I think it's number 8, you're going to see an LCM option. Hit that, and then it's going to bring up a parenthesis, and you want to put in 300, 500. Okay? So when you do that, your answer should be 1500. Now, just using your calculator for that step, you can automatically cross off options A, B, and C because they don't have the proper number out in front. So you've given yourself a better chance of being able to determine what the correct answer is. Now, the least common multiple, that's where when we look at our exponents here, we're taking a look at what the least common multiple is for all of these. So taking a look at this, oops, I copied this one wrong right here. There's no B here. That's a B to the first power. So take a look at your A's. You've got 1 in this group, and you've got 2 in this group. So that's going to be A to the third power. Oops, I'm sorry, I did that wrong again for you. The least common multiple is 2. Then when we take a look at our B squared is going to be our option. And then when we look at the C, C cubed is our largest. So your answer here is E. Okay, on number 26, I just want you to look. It's just like number 25. We found the least common multiple for our 108 and our 27. When we did that, again, you can use your calculator, and that should give you the 108. When you're going for the variables, or in the factors, the least common multiple for those, you need to take a look at the highest x value, which would give you an x, the highest y exponent, which would give you y squared, and the highest z exponent, which would give you z, leaving you with option C. Okay, on number 27, you have to take a look at the 2 problems that you have here. You have 5 square root of 7x, and we need to get it to be 5 square root of 21. So what do we need to substitute in for the x so that these two are equivalent? So the first blue line that I have drawn here shows that you need to get from 5 to 15. So that means you need to multiply by 3. In order for that to come out of the radical, from under the radical as 3, it's actually the square root of 9. Now, to get 7x to be 21, you have to take that x times 3. Well, and it's under the radical, so we would have to multiply that by that 3. So we're going to take this 9 times the 3 and get 27. Let's check our answer here. So if I put 7 times 27, 7 times 27 gives you 189. Now, if we break this down, okay, the 189, remember, we're trying to pull out a perfect square. So this breaks down to the square root of 9 times the square root of 21. This becomes 3, goes on the outside, and this is 21. So 15 square root of 21, and if you look at the original, 7 times my 3 did give me the 21. So your answer here is letter C. 28 is the exact same. We start with 3 times 38 times x, and we want to plug something in for x to make it equivalent to 6 times the square root of 19. Now, on this one, how do we get from 3 to 6? Well, that's going to be multiplying by 2, which in order to pull that out of your perfect square, or pull it out from under the radical, it had to be the square root of 4. To get from 38 to 19, 38 times what is going to give me 19? Basically what you're doing here is you're dividing both sides by the 38, and you'll get that your x equals 0.5, or 1/2. So now you have to multiply these together, and that's going to give you 2. So if you plug in 2 just to check yourself, you get 3 square root of 76. Break it down with the perfect square. That'd be the square root of 4 times the square root of 19. That's 3 times 2 times the square root of 19, giving you that 6 square root of 19. So your answer on number 28 is going to be B. Number 29, we're going to simplify 3 times 3 square root of 27 to the negative first power. Now, keep in mind that we don't like these negative exponents. Now, if you had me as a teacher, I would tell you that you're going to bump this down to the opposite side of the fraction line. So, if I rewrote that, I would have 3 over 3 square root of 27. That's rewritten, taking this whole chunk down onto the denominator. Now what we have to do is we need to simplify this because we don't like the radical in the denominator. First I'm going to break this down. So I can pull the square root of 9 out of here. That's going to give me 3 times the square root of 3, or 9 square root of 3. Alright, now you can reduce your 3 and your 9. That's going to become 1/3. So you have 1 over 3 square root of 3. Taking a look at number 29, you can see that this isn't an option. What the issue is we don't like that square root in the denominator. So in order to simplify this, we have to multiply by the square root of 3 to the top and bottom. That's going to give me the square root of 3 over 3 times 3, which is 9. Therefore, your answer is D. And number 30 says 4 times 2 square root of 8 to the negative first power. Again, we're going to take this to the denominator because we don't like that negative exponent, so I'm going to have 8 over the square root of 8. The 4 times 2 gave me this. Okay? Now, again, we don't like the square root of 8 in the denominator, so we're going to multiply by the square root of 8. That's going to give you 8 in your denominator. And then you have 8 square root of 8 in your numerator. Our 8's are going to reduce, and I'm going to end up with the square root of 8, which, of course, we have to break down. So your answer to number 30 is going to be letter D.